Can you hear me? Yes, hello. Hi, everyone. My name is Özlem Özgöbek, and I'm an associate professor at the Norwegian University of Science and Technology, and welcome to the session 10 of the RecSys conference, Applications-Driven Advances. And our first presentation is Learning to Represent Human Motives for Goal-Directed Web Browsing, and it will be presented online by Longqi.
Hi. Let's see. Okay. So actually, just Longqi, so I'm first also Jyun-Yu. So thank you for coming to this session. Just to listen to my my work. So today I'm going to introduce our exciting work about learning to represent human motives for goal-directed web browsing. So this is a joint work with Jiang, Longqi, Bahareh, Brent, and Jaime. So it will be very important for us to understand the human goals from their activities, because if we can understand their goal more, then it will just lead to have a great opportunity to help us better understand and support and guide the people to achieve their goals. For example, if we understand some people would like to chase some just like healthy lifestyle by their curious health recipes, exercise, or sleeping quality, probably we can help us to achieve their goal by projecting some focus with some filters so they can be more concentrated on their focus. So we propose the idea about the goal-directed web browsing. It would be great to help users to achieve some deep goals in web browsing more seamlessly, like some deeper goals, finance, career, personal growth. And because in the previous studies, we have already known just like the human's goals could largely direct their corresponding engaged behaviors, and understanding human long-term goals can also help us improve the user experience. So there will be lots of applications. For example, we can help users advance their goals by recommending some unseen web pages with their goals. And we can also just help us to predict if the goals are not achieved. So we can just resume the web pages. So help us to help them to revisit those web pages based on those goals. And also, we can cluster and group those web pages inside the same session by underlying goals to help users to be concentrated on their specific goals. So in this work, we focus on modeling the goal taxonomy, because the goals are usually structured and hierarchical. So in the humanities domains, lots of experts has already created and curated some goal hierarchies. So in order to model them, we propose to use the hyperbolic embedding to preserve some hierarchical structure. And we will learn some hierarchical goal representations in a hyperbolic space so that the hierarchical information can be preserved inside the embedding. Here is the example of the goal taxonomy used in our paper. So we will have 135 leaf goal nodes, which could be some more specific goals. And we have 30 parent category nodes. So those are some more general goals that cover some of the specific goals. In order to just combine all of the goals together, so we will have the ultimate final hierarchy. Then we also add the root node with a non-goal to represent the most general topic. To learn the hyperbolic goal representations, we use the loss of the taxonomy reconstruction with the hyperbolic distance of listed loss function. As a result, when we have the two-dimension just like hyperbolic representations, we can see most of the all of the leaf nodes are just listed in the outside, too far from the center point of the non-goal node. And for the 30 category node, then we can see they are more closer to the center point, and they are just like have the hierarchical relation in this space, just like two layer corresponding specific nodes. So it means that if we learn the hyperbolic embedding well, then we actually can preserve those hierarchical relations. And in the experiments, we use the 64-dimension representations for some better machine learning generalization. So based on the Go representations, we would like to have a Go estimator to help us to project arbitrary web page visits to the space of the Go representations. So we propose a weakly supervised framework to estimate the Go representations. So first, we invite the experts to write the 300 best queries over all of the Go's, and use the related query as the query expansion to be the initial data. Based on those queries, we select the weak example from the top 5 search results of the Bing search engine, so that we can have a collection of the training data with a corresponding label of those Go's. And based on those weak training data, we use a breadth-based Go estimator to help us to project any arbitrary web pages into the estimated Go embedding. And we will just like optimize this by the similarity between the projected one and the actual one. So based on the Go estimator, then we can have the capability of deriving a corresponding representation that could represent the goals behind the web page visit. So based on the Go embedding and the representation of the web page themselves, then we use the multi-head attention to model the information along the session. So based on the multi-head attention, then we can have a Go-aware visit representation for each web page visit inside the session. And for the personal history, we also use the Go estimator and the attention mechanism to derive the personal Go representation for personalization. So at the end, we will have several corresponding features as the just like Go-aware representations for both of the session and personal history. And we can use those features for the downstream application, such as the in-session web page recommender, web page revisitation classification, and Go-based web page grouping as we introduce some of the application of the Go directly browsing. We first evaluate the performance of the Go estimator. Then we treat the Go with the closest distance as the predict Go. And we can see this is the confusion matrix of the prediction. Then we can achieve about 55% F1 score for individuals and 83% F1 score for Go categories. And we first just like also analyze the top website for all of the Go category. So we can see the top website are very relevant to the corresponding Go categories, such as for the career, we have the Indeed, Career Builder, and LinkedIn. And we also conduct some just like example of the misclassification analysis. So we can see just although we have some of the misclassification, but the mispredicted Go is actually usually very close to the actual goal, such as we have the actual goal is having a stable, secure family life, but we just predict it as the feeling close to my parents, sibling, and grandparents. So it means that just although just like we have some misclassification, but actually they are very similar. And when we just focus on the embedding domain, probably it would not be a big problem. So we can see just like the square, the squeeze are just like some partition that goes into the categories. Then we can see just like most of the misclassification are still lying to the same category. And we evaluate our just like 3 tasks and use the 1 month Microsoft Edge browsing load. And for the first task, we evaluated the web page recommendation initialization, and this is a ranking task. Then we can see just like our model outperform all of the baseline methods, and the personalization also works. And the second task is the classification task to classify if the user will revisit the web pages in the future session. Then still we can see our model just like outperform all of the baseline methods. And the last task is the goal concentration. So we group the just like web page based on the goal representations and evaluate with the internal labels. So we can see just like our embedding generated by the goal estimator can outperform some conventional encoder of the text. And we also have some just analysis on the patterns of goals. So first, we can observe that just the number of goals are usually just like limited inside the station. So even just like the station could have about 60 web page visits, then it could only include about 10 goals. And those 10 goals are also usually similar to each other. And some goals may tend to have some stations with a unique goal, and they may need to some higher concentration. Like for the finance goal, you may need to be more concentrated. So it also motivates us that just like different goals may need to have the different procedure. So this also an importance for us to model the human goals inside the station. And also, we analyze the revisitation pattern over the different goals. And we can see some of the goals tend to have some shorter duration of the revisitation, like a friendship. But some goals may tend to have some longer, just like duration, like revision from others or career. So just like some revisitation pattern could be longer. So finally, I will give some conclusion. So first, we propose the idea of the goal directed browsing. It helps users to achieve some deep goals seamlessly. And we learned the hyperbolic goal representation to preserve the structural information knowledge inside the goal taxonomy. And we also show some study about our estimated goals are effective and robust and also interpretable. And with our framework, GoWeB can jointly learn the models the station and personalize the long-term goal. And our experiments also showed our framework outperform all the baseline and state-of-the-art methods in 3 different machine learning tasks. Finally, we also have some analysis on the goal patterns to demonstrate the originality and the explainability of our task. Okay, thank you so much for your listening. Please ask me if you have any questions.
Thank you. Thank you very much for your interesting presentation. If there are any questions in the room, please approach to the microphone we have in the middle. And I see 2 questions online questions. First one is from Gordon Blackadder. Why did you use a hyperbolic space, and have you compared to Euclidean space?
Yeah, we tried the Euclidean space, but the performance is lower because just like if you use the Euclidean space, you may not be able to represent the relations between the category node and the specific goals. So if we can incorporate that kind of concept, then some more general goals can be represented by the parent node. And it could cover some concept of the just like the children nodes. So the benefits of using the hyperbolic embedding is to incorporate the hierarchical structure of the nodes. So if you use the Euclidean distance, then the examples of the web page of the parent node would be almost individual to the independent to the ones of the children node. Yeah, so that's the motivation of our just like study using the hyperbolic embedding and just like some knowledge inside the hierarchical structure. Yeah, and we did just like use some Euclidean space representation, but in our internal trial, just like it could have some improvement, but the improvement is little, and just like the misclassification could be just like much more, and some as our analysis, those misclassification may not be that kind of relevant to the actual goal calculator because we don't have the kind of information about the relation between the goals.
Okay, thank you very much. I think we have to go on, but please check the online questions if there are any more. And I don't see any questions here from the room, so thank you very much again. And
thank you.
We will continue with the next presentation, which will also be an online presentation, the bias of policy evaluation for recommender systems, and it will be presented by Shota Yasui. So welcome, and the floor is yours, Shota Yasui.
Okay, so this is the presentation for the bias of policy evaluation for recommendation system. My name is Shota, and I am the second author of this paper. And this is the joint work with Yusuke Narita and Kohei Yata. Okay, here's our main contribution. We proposed an off-policy evaluation method for high-dimensional setting. Our proposed method is unbiased, asymptotical normal, and convergence rate is square root of n.